Hello everyone. Section 4b uses another type of liquid chromatography, ion exchange chromatography. Ion exchange chromatography is based on the retention of ions by the charged stationary phase. Depending on the nature of charge, it is classified as anion exchange and cation exchange chromatography. Most commonly, the supporting packing particles are made from the polymerization of styrene and divinyl benzene. The stationary phase of ion exchange chromatography is formed by adding functional groups of different charge polarity to the benzene ring structure of styrene prior to polymerization process. If sulfonic acid is added, the surface is negative charged, and it can be used towards cation analysis. If a amine group is added, it is positive charge and used for anion analysis. The retention is built upon the equilibrium between analyte ion and surface charge exchange. Using cation exchange as example, cation replaces the hydrogen ion on the surface. So the cation is retained by the stationary phase. The equilibrium constant K selectivity is the concentration ratio of product of a reactant. The large K value indicates the great concentration of cation is attracted to the surface, meaning it takes longer to elute out the column. One example to review the separation order of commonly seen inorganic ions. In general, great K value is seen in the ions with a higher charge, smaller in hydrated size, and greater in polarizability. Hydrated size shows the dimension of ions in water, or complex with water molecules. Polarizability indicates how likely the electron cloud changes under the influence of external environment, such as a field. The separation order is primarily determined by the charge, the size. The last one to consider is the polarizability. Now pause this video and think about the process. Write your answer out. The order from the first to the last peak should be chloride, nitride, nitrate, sulfate, and phosphate. As mentioned, the primary factor is the charge. Phosphate has the highest charge, 3, therefore it'll be the last one. For sulfate, 2 charges, the second to the last. The other 3, they all have the same charge, and the order cannot be differentiated yet. But for sure, they appear before sulfate and phosphate because they have less charges than sulfate. Next step, the hydrated size. Unfortunately, chloride, nitrate, and nitride have the same size, 300 picometer. As a result, the order cannot be determined yet. The polarizability must be compared. Chloride has the least number of electrons in the molecule. Therefore, it has the least polarizability and should be the first one to appear. Nitrate has more electrons than nitride, therefore higher polarizability, and it should be appearing on the chromatogram after nitride. Here is a representative IC data sample. The injection number often indicates the concentration of chloride of sulfate in the standard solution. The retention time, peak area, and peak height are indicated below the chromatogram. When performing the data analysis, you will summarize the data into a table which should contain concentration and signal. Peak area is preferred for signal. You will then plot the signal as a function of concentration. Obtain linear regression equation. Do not forget to format your figure. Lastly, substitute the signal from unknown water sample, which might be tap water, fountain water, or other water sample you prepared, and determine the concentration of unknown. Since we have prepared the mixture of chloride and sulfate, you should have one calibration curve equation for chloride and one for sulfate. At the end, you should report what concentration of sulfate and chloride is in your sample. In your report, the following information is required in the data analysis section of water. Explain why chloride was the first peak and sulfate is the second peak. Data table and calibration curves. Be sure to describe and explain them. Lastly, show the quantitation of ions in the unknown water sample in narratives, along with sample calculation. Please let me know if you have any questions. Thank you.